In this video, we are going to look at the general underlying principle governing the nomenclature of every organic compound. Don't forget to like and subscribe to the channel after watching so that you receive every update from this channel. In naming every organic compound, the first thing you have to look out for is the functional group, which is dominating in organic structure. We have several functional groups in organic chemistry, ranging from alkenes, alkynes, to alcohols, aldehydes, ketones, carboxylic acids, esters, and the rest. So to name a particular organic compound, just look at the predominant functional group present in the compound. Then you identify the longest continuous carbon chain, including the main functional group. So let's take this structure as an example. The only functional group we have here which dominates is an aldehyde functional group. Though we might have a saturation alkanes too here, but the aldehyde tends to dominate. So we count or just identify the main chain or the chain containing the main functional group. So this is the chain that contains the main functional group. Let's have this one. Here we have carboxylic acids and also alcohols. But carboxylic acids tends to dominate over alcohols when they find themselves in the same molecule. So the chain containing the longest chain containing the carboxylic acid functional group is this chain. It is being highlighted. Let's take this one. Here we have two functional groups. We have an alkene functional group here and a carbonyl functional group, which is a ketone. So the chain containing the dominating functional group here is this chain, which is the ketone, is a highlighted one. Next, you number all the carbons that are in the main chain or the main functional group. So if you have to start from the parent structure or the aldehyde in this compound, because this one is external, the functional group is outside, we tend to give the least number to the functional group. Make sure you give the least number to the functional group containing or the functional dominating group in the organic structure. So here this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So the main chain containing the functional group contains 5 carbons, and here we give the least number to the functional group. We come here to the main chain contains the carboxylic acid functional group, and we give the least number to the carboxylic acid functional group. Yes, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. We come here to the main chain, which is contain the ketone. It's this side. We can choose to start from here, but when you come here 1, 2, 3, the ketone will be named or numbered carbon 3. But you want to give the least number to the ketone, so we start from the right side. Carbon 1, carbon 2, I give here the carbon 2, carbon 3, and carbon 4. Next, you identify the substituent present and their positions too. So substituents are basically groups which are not part of the main chain. So you identify all of them, then you identify their positions too. So here, the substituent here is methyl group, and it is found on the third carbon. We have two substituents. We have methyl group and hydroxy group. The methyl is on the third carbon, and the hydroxy is on the fifth carbon. Here there is no substituent, so you can just name it straightforward. Next is identify if there is any double bond or triple bond in there, or it only contains a single bond. So here in this compound like this, have a double bond here. If it has a double bond, the parent chain in is added to the root name of the parent chain. The in here represents an alkene. So let's say if it is the parent chain, let's say a hexane, and it has a double bond, it will be named a hexane. If there's a triple bond, ine, which represents an alkyne, is used or added to the root name. This one like this, it has in, so the root name will contain, in as the main name because it's an alkene which has a ketone functional group. Next, you write the names of all the substituents according to the alphabetical order, then indicating their positions in the parent chain in front of them. You write the root name given to the parent chain with the suffix used to specify the bonds in the chain. Then you finally add the suffix given to the main functional group chain, indicating its position in the chain in front of the suffix. So let's have this. The parent chain here is pentanal. Then the methyl group here is a substituent at position 3. So this one will be named 3-methyl pentanal. This 3 indicate the position of the methyl, 3-methyl pentanal. When we come here, the parent chain is pentanoic acid. Now you show the positions of each of these substituents, then you show the numbers or their position with numbers in front of them. The hydroxy group is on the 5th carbon, so 5-hydroxy. Then the methyl group is on the 3rd carbon, so 3-methyl. Now the hydroxy has H as the starting alphabet and the methyl has M as the starting alphabet. So here the H comes before M in alphabetical order. So it becomes 5-hydroxy, hydroxy H because the H comes before the M. 3-methyl pentanoic acid. You are wrong if you make it 3-methyl 5-hydroxy pentanoic acid. Take note. Now this one too has no substituent, but it has extra functional group. So here is in is added to the parent or the root name. So both 3 in, the 3 which is attached to the in indicate the position of the double bond. The 3 in front of the in indicate the position of the double bond. Then 2 on, the on here represents the ketone, which also shows the position of the ketone. This structure means that with the 2 or with the butene or butenon, the double bond is at position 3 because the 3 is in front of the in, and the ketone is at position 2 because the 2 is in front of the on. That's how basically organic compounds are named. Don't forget to like and subscribe to the channel after watching so that you'll be updated on this channel.